Hello, everyone. Welcome to part 4 of the Introduction to D3 course. My name is Paul Buffa. I'm the head of product education at Observable, and I'm excited to go through more topics on D3 today. So, as usual, I'm joined by my colleagues, Allison and Wayne, who are helping TA. So, if you have any questions in the chat, feel free to post them there and they'll help you out. Or if you have questions in the community Slack channel, they're also monitoring that. So, feel free to post anywhere. We're happy to go through all your questions. So, we have done a lot already in this course. This is part 4 of 5 parts. We have one more session tomorrow. So far in this course, though, we've really kind of covered, I'd say, the maybe the areas that D3 you may not use it for, right? So like more common chart forms, not things that are, more expressive, more bespoke, where I think D3 really shines. And today we're going to start getting to that. So now we've kind of covered the fundamentals of how to build scatter plots and line charts and bar charts. Now we can get into areas where D3 really shines. And I'm talking specifically about how it handles changing data sets with animations and transitions. So we're going to cover today the general update pattern, which is actually kind of an older method for handling these sort of changes. And then we're going to talk about the newer method, the join method. And then finally, we're going to spend a bunch of time on transitions, which again, I think are some of the most fun parts of D3. So if there's no comments or questions so far, we'll just jump right into it. So general update pattern. What is the general update pattern? So the general update pattern refers to a D3 technique for handling, entering, updating, removing elements based on your data. And as I noted before, it's technically a deprecated pattern. So it's not something we actually recommend to use when you're building D3 visualizations, to use our new selection join method, which we're going to go through right after. But I do think it's worth covering for a few reasons. One, many D3 examples still follow this pattern. So if you see this, it's kind of helpful to know what's going on, why it's written this way, and how it works. And also, it helps you understand why this new method is better and also kind of how the new method works, because it builds upon the same ideas as the general update pattern. So the general update pattern, what exactly are we rebuilding for? What are we trying to handle? So we talked about this early on in session 2. I think we also covered it briefly in session 1, where we're talking about the data join. So we have this Venn diagram, right? And it's supposed to represent the different situations that we run into when we're building our visualizations. So we've got this situation where we've got data. So that's in the blue circle here, but we have no elements on the page. So we have, like, say, we're going to build a scatter plot. We have a bunch of data points. We don't have circles yet. So we have to build them for the first time. We have to generate those circles. So that's going to be the enter section here, right? We've got data, but no elements. The middle section, where the two circles overlap, is the update, where we've got a match for our data and our elements. So we can match the two and say, we're gonna update this element with new data, but we don't need to create new elements. And the last one here is the exit method. So this is for when we've got existing elements, but there's no longer data. So we're going to actually want to remove those elements from the page. And this is, again, an area where D3 really shines, because this is hard to do with other frameworks, is be able to handle these sort of changes and transitions effectively. So why don't we take a look at how a general update pattern generally looks. All right, I'm going to move my, actually, I think my avatar is not too much in the way. I'll scoot up a little bit. So here I've got some observable, I have some JavaScript code for observable for handling one of these updates. And you'll notice a few things here that might be a little different. Again, this is because of working in observable. We have to kind of update our cell within the cell. So you're going to see this little loop that's in there, this while true, which basically means we're going to be looping in this cell. You'll notice at the bottom, it says promises tick, just means every 2,500 milliseconds that this cell is going to rerun. So that's that little bit of code there. But I want you to focus on the middle here, which is the actual code for this general update pattern. So this, by the way, this is like a visualization. We're going to do this in the activity of just basically numbers updating. Letters updating. So it's using the alphabet as our data set, and it's just going to randomly choose new letters and update them on our quote visualization. So the first part of this, which was kind of at the top after we declared our SVG and we're working inside this loop, you'll see what's called text update. So it's this new variable we've declared. And what it is a selection of the elements on the page and a comparison to the data set that we have, which is a new set of random letters. This is how we've done all of our data joins before. So we're trying to figure out in that Venn diagram the two different states we have in terms of data and elements, and this is how we do it. We first look for the elements, and then we compare it to our data set. I want you to notice, though, there's this second argument here that we're using in the data function that we hadn't done previously. It's an optional argument, but it's something that's important when we're doing sort of these update patterns. And what it is it's an argument that allows you to assign an ID to your different elements. So it's going to be based on your data. And this ID allows for something called object consistency. So when you're making an update, when you're going to make an animation or a change or changing your data set, sometimes you're going to want to make sure that you're changing the same data point. So say, for example, you've got a scatter plot of, maybe I'm trying to think of two metrics off the top of my head. So you've got a scatter plot of the population size for people in a state and the median income, something like that. So whatever, you've got these two metrics, and each circle is representing a state. So if you update one of those metrics, you're going to change your data. You're going to want to make sure that the circle that you're changing is the same circle for the same state, because that means something. So that circle that represents, say, California, we're going to want that to update for the new California data. If you don't specify that ID, it might just update whatever state is that one in your data set, whatever row that is. So if California was the first row in the first data set, but now it's the 10th row, we're going to actually change the circle that represented California to some other state. So the idea of assigning ID is that when we're doing these updates now, we're going to check to make sure that the same ID is matching. So this is, again, a really helpful method when you're going to be updating your data sets, transitioning them. It's not something we have to do when we're just creating a scatter plot once, right? When we're just generating it one time. So you don't have to always use this ID option here within the data method, but when we're doing these updates, you do. So I just talked about that, assigning the ID. And then the second part here is that then we update those that have that one-to-one match. So this selection, we first select the elements and we compare it to our data set. And now we're just going to update those. So this is the update part of that Venn diagram, the middle section, where we do have that one-to-one match. This is ones where it does match. Oh, and there's a question from Doug about the previous ID. That's right. So essentially the ID can be text. It could be a numeric value, but you can kind of think of it as text. Because that's essentially the way it's going to be comparing them. So here we could call the update for this group of elements, and it's going to do some transition for them. But when we are simply updating elements, and we've done that comparison, there's no other methods we have to call, which is different for when we want to create new elements, the enter method, or we want to remove elements with the exit method. So here is now the enter method. You'll notice it's using that same object as before, the text update object. So it's now saying enter append text. So that's saying we're going to use the enter method now for those elements that do not exist, and we're going to add a new text element to create those. And we're going to set some attributes, and there's also, again, a little transition here. And don't worry too much about the transitions for now, because we will go through that in more depth in just the later part of today. Finally, we have the exit method, which is the method for elements that are on the page but do not have data anymore. So we want to remove them from the page. So this is the last method. You'll notice it's just exit and there's no append because we're not creating any new elements. There's actually at the bottom a remove. So it's saying we want to remove the elements from this page. This is how you essentially delete an element from the page. So if you select something and just do .remove, you will then remove that element. It will no longer exist on your page. It's important when you're doing these updates that as part of your exit is that you remove elements, because if you update the data again without removing them, you're going to get odd results. So it's important, again, that these elements are removed from the page. Now, when we've done the data join before in previous examples, we didn't explicitly write enter append or exits. We just used join, and that's going to be the more modern approach, which cover in right after this section here. But again, I think it's helpful to see this because, again, there's lots of examples of this, and it helps you understand better of how join works. So now we're going to jump to the activity section. I've gotten some feedback that it was a little hard to follow sometimes the coding that I was doing. So today I'm actually going to give you the notebook that I'm currently working on. I had been doing this, forking the original copy and then working on this copy of the original and then merging that in after class. But today, if you want, you can just follow along with me. I've also changed up the style a bit. So rather than typing out all the code, which I've heard can be a little fast, we're going to just actually uncomment codes. This way you can kind of see it. There's not going to be as much live coding. So I'm going to jump now to the notebook, and hopefully everyone has the link. So that's for the original copy there. And if you want to use the one that I'm working on right now, which again is a fork of that original copy, there's that notebook that was just shared. So thank you guys. All right, so activity 1. We're going to go through essentially what I just kind of walked through slowly on those slides, that visualization of alphabetical characters changing over time. So I've got this data set here. So it's the alphabet. It's an array of 26 letters, as you can see. And down below, I've got the code now that is going to be updating that data set. So it first declares the data set. We're using a let variable here, so it's going to be a mutable variable. And then we're going to be changing that inside this loop. And there's a lot of uncommented code here. So I've got to kind of scroll down a bit. So if you see at the bottom, we are now updating this data set every 3,000 milliseconds. So every 3 seconds, it's going to change. It's going to create a new random group. So if we go back up to the top now, you'll see that right now it's 20, then it's 17. So it's in fact working. You'll also notice, by the way, this is kind of a good thing to note with observable notebooks, is that there's this little like gray bar that appears and disappears. That's how you know a cell is running. So it's just kind of show you, oh, the cell runs, it's run again. So now what we're going to do is we're going to write, or we're going to uncomment some code for showing how to handle these updates. So if we want to make a visualization of this, right now it's just showing the array change over time. Say we want to add it to an SVG and we want to show what's updating, what's being entered, what's being removed. We're going to do that right now. So I've got some of the code for this. I've already declared all my variables for the dimensions of the visualization. So the width and height and some margins. Here, I'm going to uncomment the code for creating the SVG and assigning those widths and heights and margins. Then we've got the G tag for the margin convention to offset by the margin left and the margin top, the transform translate. And if I just run this, nothing changes because I'm still returning in this little code block here the data. So we'd have to go down to the yield. And again, here's a little different because we're not doing a return. We're inside of this loop. We're going to be using yield instead of return. So I'm going to comment out yield data. I'm going to uncomment yield svg.node. And when I run this, now I just get a blank SVG that is running every 3 seconds. Oh, the keyboard shortcut is command /. So yes, little keyboard shortcut there to easily uncomment or comment out code. So I can comment it, or I can uncomment it. Great question. Okay, so now let's start adding some elements to this page. So I've created 2 scales here for handling the alphabet. This is also a different type of scale we've seen before. It's called a scale point. It's essentially an ordinal scale, but meant for data points. So you're going to treat it like an ordinal scale where the domain is the distinct array of values. So I've made a distinct array of the enter, update, exit. Those are the 3 states. So we're going to make that our y-axis to show each state along the y. And then for our x scale, it's going to be the distinct array of letters. So there I've just set it to, I get a little padding, a little extra padding here of 10 to the width rather than 0 to the width. And then we're going to call our axis component for that scale. And if I run this, now we will see something. We'll see that axis component on the left side of the page showing the enter, update, and exit. Okay, so now that we've done that, we're going to employ our general update pattern. So as I mentioned before, the first part of this pattern is to first create that comparison, that Venn diagram, right, of the selection of elements to the data set. So we're going to call this text selection. It'll be equal to all of the letters we can find on the page. And here I'm looking for a specific class called letter. The reason for this is that there's actually text already on the page. Those axes, right? They've got text on it. So if I just do select all text, I'm accidentally going to select the axes text on the page. So here I'm using a class to make it more explicit. I want to look for a specific type of text, one that's got the class of letter. Then I'm going to be comparing it to that data set, which is the random array of letters, and I'm assigning it this ID. Given that this data set is just an array of letters, it's not an array of objects, I don't have to call a specific property. I'm just going to use D because D there represents the letter. If you've got, data from a spreadsheet where there's columns and there's going to be multiple properties, you might want to call a specific property there. So the first part we'll do is our enter. So we have our selection, and now we want to handle for situations where there is data but no elements on the page. So we're going to use the enter method and append text. And here we're going to assign all the things we need when we first create this element. So we're going to assign that class, which we only need when we first create it. We're then going to give it a position. So we're going to say use the position along the Y scale for enter. And I added a little offset because text you need to offset a little bit because of the height of the text itself. It kind of depends on the font size that you use. We're also going to give it a position along the x-axis based on the full array of values in the alphabet. So, A would always be first and Z would always be last. We're going to give it a font style. So we're going to give it 14 pixels, a little font family. I'm going to give it a fill of green so you know this is being entered. And then the text itself will be equal to that character. So here I'm going to now just run this cell, just doing shift enter. And if I scroll back up, you're now going to see every time I enter in new characters. And what's interesting here is you'll see after just a couple seconds, because I'm not doing the other states, I'm never doing the update and I'm never doing the exit. After a few seconds, we've gone through all the characters in the alphabet. So everything is just sitting there at that top row. So now we need to handle for the other states. So let's move down. And now we're going to handle our update. So here I'm just going to uncomment this. Again, we'll talk more about this transition and duration, how this works. But for now, we'll just kind of gloss over that and we'll move ahead. So what I'm doing for the update section is I'm changing the position of the character along the Y scale. So I'm now putting into the update section. Again, I'm still offsetting by 5. And then I'm giving it a fill of black. So this way you can distinguish both by position as well as the color that it's changed states. This is sort of a double encoding, right? We're encoding along the y-axis and the fill color meaning. So let's go back up and we'll rerun this cell. Our shift enter. And now what you'll see is that some characters are now moving down to the update section. And over time, after we've gone through all the letters in the alphabet, everything will be in the update section. And that's because we haven't handled the final state, right? We haven't handled the state of things being removed from the page. And that's where I mentioned before, it's really important that we remove things from the page. Otherwise, there'll never be another enter state again. We'll have gone through all the data points. So I'm going to scroll down and now handle the exit. So I'm going to uncomment this section here for text selection exit. We're going to change the fill color to red to know we're moving it from the page. We're going to set the position along the y-axis to the exit spot along the y scale. And then finally, we're going to just make the character kind of disappear and then be removed from the page. So we're going to set the opacity to 0 to make it fully transparent, and then it's going to be removed from the page. So if I scroll back up and I rerun this cell, we'll see now things in our enter state. Now, some are being exited and some are being updated. And we no longer have all the characters sitting in one state anymore. Depending on the data set, some are going to be entered, some are going to be updated, and some are going to be removed. That transition, by the way, is what makes that nice little animation happen. So it makes it kind of easier to see that shift from state to state. Here is, I think, a great example of using animation because it means something. It helps you understand what's going on. If I didn't have those and it kind of just jumped from state to state, it can actually be harder to follow. I want to just also show you a situation where if you don't have that removed, so say I took off that remove, I might just take off this whole last section here of the making them transparent and changing, doing that little transition. So I'm going to go back up. So if I didn't have that remove there, what will happen over time is that there will be no more in the enter state, right? Oh, I guess maybe I missed one character. And now it should be, I think we've gone through all the letters in the alphabet. And now there'll be no more in the enter state yet. Things are just shifting from the update to exit. So that's why we have to make sure we actually remove the items from the page, because the next time we go through this pattern and we look for all the elements, even though they were previously in the exit state, they're still there on the page. So we do have to actually make sure they are removed from the page so we know how to handle that properly. So I can just uncomment that. Go. And now it's operating as expected again. Okay, let me just take a quick pause here to see if there's any questions. Yeah, Doug, that's a good question around whether the animation is running in an iframe. It's a little bit of how Observable works. It's a little probably more complicated to explain than right now. But that's a great follow-up question for a Slack channel. We can get through more of the details of how that's implemented. All right, so let's go back to our slides. We've covered now the general update pattern. Hopefully, this is not too different than what we've covered before. Again, it's just handling for two more states, right? Before we had just always done that enter, the first state where we didn't have elements on the page, and now we're handling for states where we're updating or exiting. So now we're going to talk about the more modern approach. And again, the reason why I wanted to cover that is that the general update pattern, a lot of that same ideas are used in this more modern approach, the selection join method. So updating your visualization with the join method is the more modern approach with T3. It can be extremely concise if you don't care about any of the special treatment of states. So if we don't care to do, you know, animations, those transitions, we just want it to show us the most up-to-date version, so basically automatically removing the exited elements, updating and entering the new elements or the same elements. Selection join can be very concise. You don't have to specify any of that like you did before the general update pattern. You get a little bit more out of the box there. But if you do want to do that level of details, then you can still do that with selection join. So here is what so it's the same thing we did before in that previous slide we were walking through the general update pattern. Here's the same output, but with now the selection join method. It's actually it's not actually fewer lines of code. It's technically one more line of code. So it's this example here is not more concise, but we can actually see it's a little simpler in the way it's declared, and how it's done. So we've got again that bit of code for declaring the SVG, creating our loops. But here we've now got that SVG select all text, the data, the random letters. So that's again that Venn diagram, the comparison of data to the number of elements. And now within that join, which previously we had just specified the element that we want to make. But now within this join, we're adding the logic for each of these different states for the enter, the update, and the exit. So you can now write all that logic within there without having to kind of reuse the selection over and over again, that first part, the select all and the data. So again, same thing as before. We enter in our random letters. We assign that ID. Oh, and there's a question up here on the slides. The slides are in each of those notebooks. So at the top of the notebook for each session, there's a link to the slide. And then we're going to be again handling those different states just now within the join method. And maybe rather than just walking through each of these, because that's going to get a bit repetitive, why don't we just go now to the notebook again and we can just try to code this ourselves. So go back to the notebook, activity number 2. And yeah, I'm just noticing a few questions asking for the notebooks and asking for the slides. So just to note, at the top of every one of these notebooks, there's a link to that session slide, so you can just access it there. And if you're on the original copy, again, I forked a copy of this. If I'm on the original copy of the notebook, you'll notice too, it's inside this collection called Introduction to D3 course. And if I click on that, I can see all the notebooks that are there. So that's a great way to find it as well, all the notebooks from previous sessions. Okay, so let's scroll down here past our first example, looking for those that have the letter class, and we're comparing it to our data and specifying an ID so we know we're updating the right letters. And then we've got all the logic here for our join. So within the join, we're specifying each state. There's the enter state. So you have the enter state, we append the text, and we're going to do the same thing we did before. We give it the color, the class, the position for the X, the position for the Y, a font, and then the text itself. So we know what's inside that text. We have our update state where we change the fill to black, and then we're going to transition it for the new Y position. And then we've got the exit state here where we change the fill to red, and we're also going to transition it for this new position along the Y-axis. So as you'll notice, this code here, while it's inside the join, looks very similar to the general update pattern. Again, the reason why I wanted to cover that first, because the enter, update, exit terminology comes from that original pattern. And you're going to be doing a similar process as you did before. For enter, you're adding something, you're appending text. For update, you're just usually changing properties. You're not actually appending or removing anything. And then for exit, we're actually going to remove the element from the page. There's a question here, is remove a built-in function for G select all? No. So remove is just, it's part of the D3 library. It's a method. So if you have any selection of any element on the page, you can use remove to remove that element. So if I rerun this, well, now I'll just see that exact same thing we had before. I think before I might have slowed down the animation a bit. So this one might be a little bit faster, but it's going to be the exact same process as before. So taking a look, we also have a question. Why do we need a call method in update and exit? So let's go down to that. So this call method allows us to actually, if we want to then reference the object itself and make a transition, we're going to use the call method there. So you're going to see the same thing done when we build our axes components. It's a similar process. So we're using the call here for the update and exit to handle that transition. It's not something we've done for the enter because we're not doing any transition there. So those two are treated a little bit differently. So let me actually show you, if we didn't care about doing any of those transitions, and we just want to have an update, there's this other version of this that I've also commented out. So I'm going to uncomment that. So this here, this is doing the join like we've seen before, right? Where we just wrote a join that says text, so we're going to append a new text element. We have assigned the ID here, though. But this is like how we've done our scatter plots previously. So if I just go back up to the top now, after uncommenting this, I believe I've rerun it. So you'll notice that we're just always in this enter state because I didn't specify here to handle for the update state, right? I had to add that special logic to say move it along the y-axis. But what it's doing is it's just giving us all the letters in the alphabet that are part of that new data set. So it's always going to remove elements when they're no longer there, and it's just going to enter an update at the same time. Again, there's no special logic here for handling the update state differently. So they're all appearing along the same point along the y axis. But this is a nice way if you just don't care about necessarily doing transitions or handling update and enter differently. You can just use join and it'll automatically remove the old elements from the page for you. So this can be where the news method, the selection join, is very concise, right? You don't have to give it any additional logic if you don't care about handling those differently. All right, great. Let's go back to our slides. So we've now learned a big part of D3 is how to handle different states of data. So with the different elements on the page. Now we're going to talk about a really fun section of D3, which is transitions. So I showed you before some examples of transitions. We said we're going to go through it later. We're going to go through that now. So what are transitions? So it's a method in D3 for basically animating elements on the page, moving them, perhaps along the X or Y axis, changing fill colors. It's a way to transition an element. So what we're doing here, at the end of the day, is we're essentially taking an element and we're interpolating it, right? So we're figuring out the states between two different points. So say if we have an element start at point 0 and one to 100, the transition is going to figure out that between those 2 points, we have to go to 1, 2, 3, 4, 5, 6, 7, etc., all the way up to 100. So it's going to change that position, right, to all those different states until we reach the final point, which is 100. So here's an example of just a circle on a page, right? So very, very simple. And there's the code underneath for it. So I just declared an SVG, added a circle, gave it a radius of 50 pixels, positioned it right at the 50 point along the X and halfway along the SVG on the Y. Now, if we add a transition, you'll notice at the bottom there, and yeah, there we go. You can see it updating, although my avatar is kind of blocking it. Why don't I just scoot that down? There we are. So now you'll see I added a transition after I declared the initial state of the positions and the radius. I gave a transition for moving along the X, right? I changed the CX attribute, so the X coordinate for the circle, to the width minus R. So it'll be to the full width, subtracting the radius of the circle. So now it just moves straight to the right pretty quickly. That's essentially how you implement a transition. So you want to give it kind of this original state and then the end state they're going to go to. And this is the default, speed, the default method in which it interpolates. We can chain transitions together. So if you want to have multiple transitions in a row, you can do that. So here I've got the same transition as before, but then I added another transition afterwards to move the circle back to the original position. So it kind of moves to the right fast and moves right back to the left. There are many different settings to transitions that you can do to make them really feel unique and fun. So here I've added in a duration to the transition to slow it down. So now it's based on milliseconds. It's set to 2000 milliseconds, so 2 seconds. And it's now slowed down that transition greatly. So you can kind of a little bit easier to see it move back and forth along the page. So there's lots of fun different settings to our transitions. And I want to spend a good chunk of time on that today because I think, again, it's pretty cool. There's a question there. Does D3 support tweening? Yes, you can write your own custom tweening functions if you would like to. So that's a way to kind of handle those in-between states where tweening comes from. So you can do that in any way you like, although there's a large library of different tweening options called easing methods with D3. So you have a lot you can play around with, and they have different settings and parameters. Okay, so we're going to jump to activity 3 and 4, Actually, these are the activities we can do for the rest of the day. So this is going to be the next 20 minutes or so is going to be these two activities. We're going to talk about a few different types of transitions, implement them, and then we're going to do kind of a more realistic example of actually updating a scatter plot and handling those transitions. So I'm going back to my notebook. Hopefully everyone's in the right one. I'm going to scroll down and go to activity number 3. Okay, so I've got 5 circles on this page, and we're going to implement a few different types of transitions. Oh yeah, and there's a link in the chat there for more info on transitions if you want to see some of the options. So we're going to work through these prompts and then try out a few different easing methods, which will be fun. So the first one is we're going to make each circle move to the right. So we're going to make all the circles on this page move to the right of the screen. So here's the code for generating this. There's not too much code here. It's a pretty simple, quote, visualization. Declare our SVG. We've got a scale. This is using, again, a point scale for the domain. And then we've got the circles being implemented with the selection join method, giving it a CX position based on the index. So we're not using the data, we're using just the index value. This is, by the way, a fairly common way of writing this. So if you're not using one of the values, like you're not using the D values, using an underscore there. You might see that in a lot of examples. So if you're curious why it's not D, that's why, because we're not using it. You can still write D and it'll work just the same. Then we're going to set the Y position to the height divided by 2, so it's in the middle, and the radius is equal to 25. So what we're going to do now, just at the end here, is add our transition. We're going to call the transition method. And then we're going to give it some new position for the X. So we're going to move them to the right. So I'm going to just copy and paste the CX and change this logic here to the width minus R. Oh, I'm sorry. R is not defined. It's hard-coded in here. Let me just define that real quick. I'm going to make R equal to 25. Now, it moved pretty fast. I'm also going to take out this hard-coded R and just replace it with the variable I created. I'll rerun this again. I'll do that Shift-Enter. And wow, yeah. Jumps right across the page, right? Pretty quick. So the second prompt here is, let's make this move slowly. So let's add a duration here so it's not so fast. We can see this happen. It'll make it pretty slow. I'm going to make it 3 full seconds. So like an eternity. There we go. You counted that in your head. It was 3 seconds. And what I think is really interesting about this, if you'll notice, is that because the circles are different positions along the X, some are going to move faster than others because they all have 3 seconds, right, to get to their final destination. Some are closer than others. So the ones that are closer are going to essentially move slower because they're only moving a short distance. And while those that are further away are going to move faster because they're moving a long distance. Oh, just noticing the question there. Yes. So we're just doing this example now, but the next example will be in a more real life situation of actually changing a data set, like a real visualization. This is just to teach you transitions. Okay, so we moved it slowly by adding in a duration. And one thing that's pretty neat is that you can actually, within this duration method, you could call the data again. So if you wanted to, say, use the data within here, and given that the data is numerical, I could do maybe like d plus 1. The first object starts at 0. So I'm going to do d plus 1, and we'll do that times 1,000. So notice each have a different duration, right? And because the first one, the value of d is the smallest, that makes it go the quickest, right? Because we're multiplying by 1,000. So d is equal to 0. So 0 plus 1 is 1 times 1,000 is 1,000. For the second one, that'll be equal to 2 times 1,000. So that's 2,000, right? Et cetera, et cetera. So now we're treating these all a little differently. We can also do that with another parameter for transitions. So we can set a delay. The delay does just what it sounds like. it's going to wait to do that transition until it's hit that threshold, which will be again set in milliseconds. So if I just do delay 1000, what it's going to do for all the circles, I mean, I'll set this duration back to 3000. What it's going to do for all the circles, it's going to wait 1 full second, and then it's going to do that transition. So 1, and then it's going to start to move. And same thing as before, we could set this to a variable in the data set. So we can make it equal to D. You do D times 1000. So maybe each one is delayed by 1 second. And now you get this nice kind of, I feel like when you do these sort of details in your transitions, it makes them feel a little more natural, right? So it's like one's moving at a time. And a lot of times you're going to play around with it, see what works well. Maybe it's better to delay by 5,000. Trying to get it so like when the first circle passes the second circle starts to move. So it looks like maybe it's a little bit more. Maybe it's like 750. There we go. But pretty fun. Makes it feel a little bit more lifelike. Now we'll do an example of chaining the transitions. So we're going to move them to the right, then move them back to the left. So I'm just going to copy and paste the same logic I had here for the first transition. I'm just going to chain them. And then I'll change the position back to R, so back to the radius of the circle. So now if I run this, you'll see they all move. And then that first one already starts moving back because it's got the smallest delay, right? They all went back to the same position because I didn't set them to be in their own positions. I just hard-coded. They're all going to be back to the original 25 pixels. If I want to, I could put this back to the original settings. So I can copy this attribute, paste this here. Now they're all going to move to the right, and then they're all going to move back to where they started. Again, what we're doing here as we're making those transitions, the transition is figuring out each of those steps as we move along the page. It's figuring out that interpolation. So if I looked at this inside the console, and actually looked at those elements, which is, all right, it's a little too big. Let me make this a little smaller. I'm going to scroll up and let me learn. There's all my circles, right? So there's my SVG. And there's all the circles on the page. This little part up here keeps updating because remember that's on a loop, right? That keeps changing every 3 seconds. Okay, so I'm going to rerun this and watch how you can see here, right? The coordinates are changing over time. And depending on how far it moves, it will determine how many units it has to move, right? So for those that are only moving a short distance, it's going to be more granular, that movement. It's going to be moving at a smaller step, while those that are moving a large distance going to be a quicker step. So we can change the methods in which we ease these transitions, the way we interpolate between two values. So it's called D3Ease. Is a great notebook I linked to here. I won't go through all this right now, but if you want to see the different type of methods, it shows it along an X and Y axis, how it interpolates. So there's a linear, that's the default. There's a quadratic ease. There's ones for easing out or easing in. There's a ton in here, so definitely worth taking a look at because they get pretty fun. I'll just quickly show you one of my favorite ones, which is, I think is like one of the maybe silliest ones. So I'm going to add, again, like I did before for duration and delay, I'm going to add ease. And now I'm going to use one of these easing methods. So I'll do d3.ease, and we're going to do ease elastic. So this easing method is going to do kind of what it sounds like. Give it kind of a feel like you're pulling something, like you're bouncing a rubber ball or something like that. So here we go. I run this. Oh, maybe it's a little too fast. All right, here, let me slow it down a bit. Here, I'm going to slow this down, and so you can see a little bit better. And I'm also going to allow overflow because it actually, when you use an ease elastic, it'll literally go like past your destination and then come back, which is pretty fun. So I'm going to remove that transition. Let me make this a little longer. I'll make it a full 10 seconds. Maybe that's too long. I'll make it 6 seconds. And I'll change the overflow to visible, style, overflow, visible. And if I rerun this, whoa, it's off the page. Oh, the overflow doesn't seem like it's actually working. I'm not sure why. Oh, I think we're actually beyond the bound of the notebook itself. If I made this a little smaller, here, if I made this like 500, you can see it go over. So it actually goes past the point and then kind of lands back and it kind of bounces back and forth. So again, these are just kind of fun ones. There's lots in there, and you can really kind of make your visualizations come to life. So in the last 14 minutes, let's go through a more practical use case of updating a visualization with a data set and then handling that with transitions. So below here, I have got that original scatter plot we built in session 2 using this iris data set. But I've limited it. I've only used one data set at a time. So remember there was 3 different species in this iris data set. Well, now what I've done here is I've used it to only look at one species at a time, and I've added some buttons to the top of the page. So if you look at the code here, most of this is going to look pretty common to you. We've done this before. There's just a few things that are a little different, right? We've added some buttons. So that's this little block of code here. We're doing the same method that we do for our visualizations to add buttons. We're basing it off the data, and we're appending it to another element. So here I've declared a div. I've added buttons to that div. I didn't add buttons to my SVG because a button is an HTML element, not an SVG element, so it wouldn't work within SVG. I have to do it outside of the SVG. So I did it within this div here. This data set that I'm using for this, it's using a function called D3 groups. And what it does is actually groups the data by whatever field you specify. So here I've grouped it by the species. If I just copied and pieced this line out, I'll just take this little bit of code, put into a new JavaScript cell so you can inspect it. See what it does is it's taken my iris data set, which was an array of objects, and has turned it into an array of arrays. So actually, just to demonstrate, here's the original iris data set, right? An array of objects, there's 150 rows, and now it's made into an array of arrays, where if I open those, each of those is equal to 50. So there's 50 rows for each type of species in the iris data set. If I open those, I'll see those raw results itself. So the reason I'm doing this is that I'm actually going to bind this data to the buttons. So if I inspect one of those buttons, right, I'm on the Setosa button, and I do that little $0.0.__data__, you can actually see that that data for that button, it's bound, right? So I can actually access all the records for the Setosa species by interacting with that button. Okay, so we've now added the buttons. We've got data bound to them. The rest of this is our normal scatter plot example. So no surprises here. The only variation is that rather than just creating an SVG, I'm actually selecting this div first. So it's appending to the same container as the buttons are. But everything else is the same. And if I scroll all the way down, I've got a little bit of logic here for handling what happens when you click on that button. We're going to talk a little bit more about interaction tomorrow in the last session when we do event listeners. So for now, I'll just say, essentially I've added a way for us to handle it when you click on that button. So if I want, I could do again like console log like hello, and I could even do one for maybe the data. Show you that, yes, that click is working. So when I click on that button, we're going to see that in the console. Oh, quick question was, sorry, how is the data bound to the buttons? The same way we've bound data to everything we've done so far in this course. So we're literally going to look for the buttons on the page. They don't exist yet. We're going to then call the data method, and then we're going to join those buttons. Okay, so I've now added a listener, and I added some console logs. So now when I click on one of those buttons, you'll see hello comes up and the data set. So we know it's working, right? We could test it for each one just to make sure. Looks like they're all working just as expected. So I'm going to close this again. So now we know we've got the data when we click on those buttons. What we're going to do is we're going to use that update pattern, the selection join, to handle for that. And then we can start adding in some different transitions if we like. So what we can do is quite simply, I'm going to remove these console logs. So what we're going to do is we're going to select our circles. So I'm just copying and pasting this code here. A little formatting. And now the data is going to be equal to the data that's bound to the button. As you might have noted before, it was an array where you had the key of the species and another array of the values. So it's going to be equal to D1, the second item in that array. And now we're going to simply copy and paste all of this. Right? And what this will do is, when we run this cell, every time we click on this button, it's now going to change for our new data set. Now, here it doesn't really make sense to add an ID because these are all different data points. This is not going to be an example where you want the same point to move, right? So what we could do is we might just want to handle for the enter state and the exit state so that we can then make the new ones kind of appear in a nice, fun way and the old ones kind of slowly disappear rather than kind of just jumping around on the page. And again, I think that adds a lot of value because it helps you understand when you see that with an animation that it is in fact new data points being created, right? It's not transitioning. This is a different set of data. So adding animations and handling flow states really can add value to your visualization. So, I'm just going to scroll back up and just copy and paste some of the code we did for that so we don't have to rewrite it all again. So that's this code here. I'm going to first uncomment it. This is when we did the selection join method. I can even comment out this one so we don't have some cell with some broken code. So I'm just going to copy and paste this. And I'm going to scroll back down to this example. And we're now going to add that in to when we click on our button, right? We're going to add this join logic. So I'm going to go here all the way to the bottom of the page. And instead of just saying join the circle, we're now going to paste this join logic I had before. So now I'm just going to overwrite this with what we want to do with our new, for this data set, and then we'll have some that works pretty well. So I'm going to, instead of append a text, I'm going to append a circle. So I'm going to copy and paste this. Now I can actually just copy all of this code here. Here we are. I don't need that semicolon at the end. Format that a bit. Okay, so now it'll handle the enter state. Again, there's not going to be an update state, so I'm just going to remove this block of code, given that it's a different data set each time. And then for the exit state, I just want to make it transition nicely so it kind of you can tell it disappears off the page. So maybe I'll add one where it first just makes the circles turn small, like they kind of just slowly shrink, and then it'll be removed from the page. So I will then make the radius, hit the radius to 0 pixels. And then after that's done, it'll transition them to be removed off the page. Looks like I just got to delete that line there. All right, so now if I rerun this, scroll back up and look at the results. So here, again, nothing happened yet because we have to first click on the button. So then I'm going to click on this one and change the data. It deleted the old ones. Wait, it did not add the new ones. Wait, let me just double check. Maybe I had something wrong there. All right, so it did correctly remove the old ones. Let's see here. What am I missing? So enter append circle. We've got the positions. Hmm, what am I missing here? Why are these not appearing on the page? So we should have what we need. We've got the enter logic. We've got the same attributes. It's got the radius stroke. Very interesting. I wonder if we maybe need to include that update method. I didn't think we do, but let me see if I'm getting any errors in my console. No. Yeah, why don't we test clicking on the button again and seeing what happens? Because maybe it's that's funny. Maybe it's because I'm not assigning an ID there, but let's just check. So, okay. So it looks like it I think I know what's happening. Because it's not assigning this ID, it's actually first just creating all the points and immediately removing them. So here we might have to set an ID. Let's find one that's going to work well. So let's see. We have to find a unique string here. I guess I can just kind of concatenate the values together. I can also just try assigning it to the full data object itself. There we go. So it is happening. It's just that transition's happening really fast. All right, so I just had to set my ID. That's way it knows to correctly handle each state. So let me just slow down that transition. Yeah, that's right. We could also use a row index, although it's going to be the same for each data set. So it actually would treat them the same way. You'd have to be careful using that. When you want an ID, you want something that's going to definitely be unique. So I'm just going to use the full data point, which will be all the different columns there. There's no ID in my data set. I could generate one if I wanted to, but this is a simpler method. All right, why don't we slow this down? And yeah, there was a question there if we actually need to do another transition before the remove. You don't need to. It will just by default. I mean, like basically, if you want to like add some additional logic for the first one to take a certain amount of time, then afterwards it then removes it after a certain amount of time. You could add this, but you could also just have one transition, and when that transition is done, it will then remove. So let's maybe set this to a longer duration. Make the duration 2 seconds, something like that. And then scroll back up, and I click on one. I'm getting a weird thing where it's only selecting one. So I've got to tweak through my logic a little bit here to make sure it's working right. But this is, I think, a more practical example of how you'll be able to update a data set and change it over time. All right, in the last minute here, just want to see if there's any more questions. There's one here if you need to add a remove on exit. Yes, you do. So I think when you just do a simple join without specifying the enter, update, and exit states, you don't need to specify that. It'll do that by default. So it'll automatically remove the elements from the page for you. But if you do want to handle that differently, you can just write that inside the join method. Let's see if there's any more questions here. I think we've covered about everything. Great. So that is session 4. And tomorrow we're going to be doing kind of a bit of a grab bag, right? The last session here, we're going to talk about a few different concepts. So I'm actually going to cover what we didn't get time to do yesterday with Stack, which is thinking in D3, talking about hierarchical data sets and how you want to handle that when you're building your D3 visualization. So we get into data structures, visualization structures. We'll do a little bit more on interaction and event listeners, so how we did that click method there and what that means. And then we'll spend a little time just talking about how you can keep learning. How, if you want to learn more D3, what's the best method for doing that? So come back tomorrow, same time, same place. And thank you, everyone, today. We'll see you again soon.